Off in the salty ocean, off where the waves roll free. The sparkling water rises, then crashes to the sea. Out amongst the breakers, you'll have no need to fear. It's true, it's the blue frontier.
Welcome to our latest episode of Rising Tide, the Ocean Podcast. This is David Helvarg, and my trusty co-host is Vicki Nichols-Goldstein of the Inland Ocean Coalition.
Hello, everyone.
In October, NASA launched the Europa Clipper on a mission to the volcanically active Jupiter moon of Europa to investigate if its subsurface ocean might contain life. It'll get there in 2030. But since hearing that, I've wanted to invite our next guest onto the show. Longtime oceanographer and NOAA scientist Kathy Crane was a graduate student at Scripps in 1977, and the first person to identify where some volcanic vents might be found in the deep ocean of the Pacific, the Galapagos Rift it was called. She was topside as her research partner went down to the vents aboard the submersible Alvin and shocked the world with the discovery of a big living colony of clams, anemones, red-feathered tubeworms. This discovery rocked the world of science with the realization that the universe doesn't just have photosynthetic life, but also chemosynthetic life that can live off hot chemical emissions, the kind that might exist below the surface of the ocean moon Europa. Before we get into your role in that world historic discovery, Kathy, or your years at sea in the Arctic Ocean that you nicely describe in your book, Sea Legs, Tales of a Woman Oceanographer, why don't you tell us how you first connected to the ocean?
As a pretty athletic child, I guess, I really wanted to be an explorer of any kind. There was a time, since I grew up around Washington, D.C., my parents had gotten us a subscription to talks at the National Geographic. I was taken on a talk by Jacques Cousteau, and I just loved it. And since that time, I thought, I either want to be an oceanographer or an astronaut, something that takes you into a different realm from which we live in here on dry land. So that was really what really spurred me on to do this and to go ahead and try to gather all the stuff I could get that would allow me to be accepted at graduate school. So I decided to go to Oregon State University. I majored in geology because undergraduate students could not major in oceanography at the time. And it was a difficult thing for me to actually graduate in geology at Oregon State because they took no women in their field camps, summer field camps. But you couldn't graduate unless you went to field camp. So catch-22. So I had to look for some place, some other university that would accept females in their summer field camps. And I went with one in Northwestern University and worked in the Caribbean Sea. And so mapping coral reefs and all of this stuff. So I really got my feet and everything else wet in that adventure. And I was able to graduate from Oregon State. And I applied to Scripps Institution of Oceanography. And I was actually really surprised when I was accepted. I was surprised, but I'm very happy.
So you bought a surfboard and a swimsuit and you headed to San Diego.
I never really learned to surf much later on. I never got above my knees on the surfboard, but I didn't have any opportunities to do it.
You did start going on shipboard expeditions as a grad student there at Scripps.
Oh, absolutely. Very early on.
But there's still some prejudice, I remember you telling me.
Yeah, I started going to sea my second year at Scripps. And we used to have to go through these advisory talks by a certain individual, the women did, about how not to act or how not to dress on board ship. And they wanted us to dress in very heavy sweaters and bulky pants. This is at the equator. And now all the guys are out there in skinny bathing suits and everything. It was really ludicrous. The fear was, of course, that we would just bad influence on the young men.
Or distract them from that important scientific work that they were conducting.
We were considered the new girls in school by you call the Beach Boys song. And
bad luck on boats?
Yeah, women were bad luck on ships. And even worse was I like to whistle. So whistling and being a woman was a double whammy against me. They said, well, you bring a storm.
You whistle, you bring on a storm.
Scripps was really interested in learning how the volcanic mid-ocean ridges acted in the Pacific as compared to the mid-Atlantic ridges, because the institutions on the East Coast had mapped out large cross-sections of various rifts, and they were very deep rifts inside of with volcanoes in the middle of them and huge cliffs on the side. Looking at this from the perspective of the Pacific, it was looking like everything was inverted. And so the idea was that there must be a heck of a lot of heat coming out of this place in order to build up volcanic edifices so high. And that was always a huge question, was measuring the heat flow. Yeah. What people used was a lance and had thermistors along it. Then you can measure the difference in the temperatures and conductivity and all this all the way up the lance, and then calculate how much heat was escaping out of the sediment from the seafloor. And it wasn't nearly enough heat to account for all that heat that was predicted. And so where was the missing heat? That was the question. Where is the missing heat coming out from the mantle? And I was decided to focus on looking at this big absence and trying to figure it out. So we students fixed this instrument up. It was a cylinder, we put on all kinds of instruments, black and white cameras. We had a cable that transmitted information up to the ship, which was really novel at the time in the 1970s. It was a coaxial cable. We had magnetometers, we had gravimeters, we had water samples. And I put on a long thermistor chain, which was intended to look at the temperatures of the water above the middle of the mid-ocean rift. And that was my first attempt with other scientists to look at this stuff. And we did find some things. That was one expedition I was on. Another one was to the Galapagos. And during that time, I will say when we went to this Galapagos, we called them spreading centers at the time, not rifts. That was an East Coast terminology. But when we went there, we had to go to the Galapagos Spreading Center as a foreigner and not Ecuadorian. We had to go 200 nautical miles away from the Galapagos Islands. In other words, get out of the national territorial waters of Ecuador, which owns the Galapagos. So we went exactly 200 nautical miles and plus one and lowered our deep tow instrument. There had been an expedition to that spot prior to us going. And there was a colleague of mine named Bob Dietrich who had first attempted to look for hydrothermal vents using a thermistor that only had one thermistor on it, a chain, which dangled down very close to the seafloor. And he got some very interesting things, some very small temperature spikes. I would say less than 1/10 of a degree. So during our operations, I took all of his information and I plotted everything out on a map. And in those days, maps were made by hand. Everything was done by hand. And we then lowered our instrumentation and ran it along the crest of the Rift Valley. And we photographed some sea life on the seafloor, which in itself was almost a miracle. People didn't think anything could live down there at that depth. And we photographed some clamshells, which when we figured out how big they were, that they weren't your ordinary clam, they were about 12 inches long or larger. And our esteemed chief scientist said, oh, they must have been dropped by a Navy ship during a clam bake they have on the fantail of their ship. So I named it Clam Bake 1. And there was a temperature spike right at that spot. And so what we did, we continued to look down the Rift Valley for other places and to map out. We had black and white photographs. Everything was black and white. We had no color at the time. But it did transmit up to the ship. So we were very excited about this. And we were trying to find more and more sites that would be sites where we would find hot water coming out. And we didn't get any shimmering water at the depth where we were. We weren't down close enough to the seafloor on this expedition to do that, to see that. But we did see animal life associated also with spikes in temperature in the water column. So that was pretty darn exciting.
So you had enough in this cruise, enough of a discovery to come back with the Alvin, with the deep diving submarine.
It was my thesis work. And the way I was asked to go on the expedition was I had all the maps. And I had the coordinates of this transponder, this beacon, sitting on the clam bake. And I had all of the codes to get back to the site, which was, of course, extremely important. So I was the navigator on that expedition. And I also worked a lot with the bottom camera system from Woods Hole that didn't have any coaxial cable. They used to call it the dope on the rope. Just took pictures. It took pictures. And the pictures are beautiful. The first divers, being the navigator, I directed them to, I said, look for the spot in the middle of all this black basalt and glassy basalt. You will see popping out these clamshells that are brilliantly white. It's white against the black, and you'll be there. And that's what they did. And then they discovered that there they could see the shimmering waters coming out, and they measured the temperature up to 12 degrees C. It was about 10 degrees higher than bottom water temperature in that part of the ocean, deep ocean.
And do you remember the moment they reported seeing life?
Oh, yeah, I remember. I was right. I wasn't there in the sub, but it was just extraordinary. We can't believe it. There's all this stuff down here. It's amazing. It's shimmering.
And what was down there, in addition to the clams?
There were crabs, Galatheid crabs. There were little floating creatures. We used to call them dandelions. And of course, we were geologists. We weren't biologists. But we did send pictures of these things back to Woods Hole for the biologists to identify. And they had no idea what these things were. So they sent back a radio message to the ship, stop everything, gather anything that's alive, that you think is alive, bring it back to the surface and pack it properly. And of course, we didn't have any proper tools on board the ship to preserve biological specimens. So we used vodka, actually. we had a lot of vodka on the ship.
A sacrifice you were willing to make for science.
The really impressive thing was how much we did with so little computer power. There were no personal computers. We calculated everything by trigonometry with pens and pencils. And if we were lucky, we had a calculator with us. So it was really, I don't think present day oceanographers could really imagine how you can go out someplace and using such evidence that we had and find these spots.
And let me say something here, which is
yes.
Because I often hear about how Bob Ballard discovered these deep sea vents. In the 50s and 60s, Bruce Hazen, a geologist, and Maria Tharp, a cartographer, discovered the ocean spreading in the Atlantic that led to the theory of tectonic plates, of ocean spreading. And at the time in the 50s and 60s, Bruce claimed the credit, and it wasn't for another 50 years that people recognized Maria Tharp as central to that. And I just say what you just described is you found the vents. Nobody knew what was down there when they went down there. There was life.
Nobody knew. No, we found them actually on the previous year in 1976 with using the deep tow. And this was the missing heat that nobody could ever calculate. But it makes sense. You have volcanoes. And you have water, and it makes hot water. I don't know what's so difficult about that. Really.
And hydrogen sulfide that would be poison to us, but that was these animals had bacteria that convert it to energy that give them life.
Do you love the salty characters and ocean champions we have on the Rising Tide? So do we, and we're dedicated to bringing inspiring stories and voices that make waves. But here's the catch. We need your support to keep the tide rolling. A tax-deductible donation at bluefront.org will help keep the Rising Tide on the air and online. If you're ready and able to amplify these salty voices for the sea, dive in with a donation, big or small. Visit bluefront.org and join the movement. And now, back to the show.
Kathy, can you tell us the significance of these deep thermal vents? Like, why is this such an amazing discovery? And how does that really open up opportunities for understanding how the ocean works and where life formed?
The discovery led to tremendous biological discoveries. Really important about what is the nature of light, because there's no sunlight down there. So the animals cannot live off of sunlight. And so they must get their energy from the chemistry in the hot vents. And a lot of different forms of life are doing that. And so there was speculation in the biological community about, wow, we have a new sphere of life on Earth that we never knew existed. And nobody could ever perceive of that. So it was an incredible result. After this discovery got out, there was like an avalanche of people wanting to get into this subject and push everyone aside. Everyone who was working on it, all these guys come in, and really it was crazy.
In 1979, you got to go down there yourself, right?
I went down in 1977. I was actually on the Woods Hole mapping team and as a navigator. And I first visited the tubeworms. I named all the spots. There was one Eden and then one east of Eden. They are truly spectacular. They look like, actually we called one, the biggest one, Rose Garden. They look like roses. They have a crystal clear, almost a translucent white stalk. One tubeworm can be several meters long, and they're fixed to the seafloor, and then they just sit there and drink all the chemistry they can. The very top of the tubeworms are pink and red, and when they open up, you see a lot of like petals, like pink petals on these tubeworms.
So the Atlantic, they discovered continental drift, but you discovered new life in the universe. So I'm curious, as a child, you wanted to be an oceanographer and an astronaut. Did NASA ever call on you before they started organizing to go look for similar life in the solar system?
I was a finalist in the space shuttle program. Unfortunately, my eyesight was not good enough for their requirements, so I couldn't participate as an astronaut. And I really wanted to do it at that time. The space shuttle program was really focused on environment of planet Earth.
It's amazing. Your career evolved even further afar, where you spent a decade with Russian scientists, and especially during those Cold War tensions. So I was curious, what did those collaborations look like, and what were you working on?
Mm-hmm. I mentioned previously that after this information was let out to the scientific community, there was like an avalanche of people who wanted to claim this as something they wanted to do. And so many of us who were the first ones there really felt pushed aside by everything. And I really did not enjoy that. I didn't want to be in a whole competitive world. It was really bad. So I was asked to go on this expedition, a Swedish icebreaker expedition, which is sponsored by the King of Sweden. And he actually was on board the ship. And so we did all kinds of science, which I enjoyed, like a whole suite of biology, polar bears, under ice, in the ice, gravity, geophysics, and sediments, and everything, because this was a lot of fun for me to go to, because It also had not ever been mapped in any real capacity.
And you're talking about mapping under the Arctic ice, mapping the mountains there.
Yeah, this was 1980. And we had some Russian jets zooming over us and buzzing our ships. And originally, the chief scientists had asked the Russian participation on the expedition, but the powers that be there wouldn't allow their scientists to come along. So it was very interesting, and socially as well as scientifically. It was very exciting, and I decided this is so much fun. I really want to go out with all these people again and investigate the Arctic, see under the ice. And I brought back some of the first photographs of the seafloor under the ice, and it was absolutely beautiful. It was as colorful as a coral reef.
This is a whole new world that's opening up in the 80s and 90s, the submarine aspects of the Arctic Ocean. Didn't you discover a 14,000-foot mountain there, submarine mountain the Navy didn't know about, its submarines could run into?
That was much later. We were on an American icebreaker. And so we were mapping. We had the chore to map everything to see how much seafloor. We didn't know much about the seafloor depths or anything like that. And we did find, we were mapping out this whole region that we could, and we came across, I remember I was on watch, and the maps we had didn't show anything there. And we kept pulling the instrument up faster and faster to try to keep it from ramming into the side of this mountain.
That is a big thing to miss.
Yeah, I would say lots of things like that in the Arctic and all over the oceans, actually.
To bring it up to the present, when you went to the Arctic in the 80s and 90s, were the scientists aware of the rapidity with which fossil fuel-fired climate change would affect the Arctic, the loss of sea ice, the fact that it's now warming 3 times faster than the rest of the world?
More than half of the Arctic coastline belongs currently to Russia, formerly Soviet Union. And the big worry was that the Soviets had this 5-year plan. They wanted to turn one of the rivers around, reverse it, so it wouldn't go into the Arctic, but would flow down to one of their desert areas and fill up the Aral Sea, which has since gone dry, mostly dry. And the worry was that would change the whole balance of salt water and fresh water in the Arctic, to the point that it would upset the whole physical oceanography, where currents form and deep water forms, and deep water goes down through the Atlantic and all around the Earth. And it is actually a driver for the Gulf Stream. It pulls up the Gulf Stream to replace it. So that was the worry at that time. But later on, when we started going back to these places, and we started to get satellite imagery on a yearly basis, and became pretty obvious the sea ice cover was diminishing. In the 90s, we were still doing that kind of work with the Norwegians, and then finally, that was when the Soviet Union fell. And I was working at the Naval Research Lab then. We started building up international programs. Our task was to get to know and invite as many Russian scientists as we could to have them process all the data they have. They have been in the Arctic since the 1800s. And so they had a tremendous amount of information, from biology to geology to everything. So our goal was to process these data, and we put everything together. We're putting all the data we could find together. It was revealed that there had been many nuclear reactors dumped to the bottom of the Kara Sea, and during some missions, and they even had the fuel rods intact. And so there was a tremendous worry. Has this stuff broken up, and are the radionuclides spreading all over in the bottom currents there? So this was the driving force.
And you found they didn't pose an immediate threat to the...
What happened was something that happened with the leadership in Russia saying, the foreigners can only investigate one latitude and longitude, 1 point, 1 point on the seafloor, which wasn't going to cut it. So we were instructed by State Department to pick up and come home.
So what do you think the Arctic today is versus the years you were there? How radically is it changing, and what's your thoughts as a scientist?
Yeah. I later went to take a job at NOAA in the climate office, Arctic research. I was a program manager for Arctic research. And we set up the program called the Russian-American Long-Term Census of the Arctic, because we realized we didn't know anything about what lived in the Arctic, certainly not on the seafloor. Nobody knew. There's hardly any expeditions there that looked under the ice. We didn't know how thick the ice was. We didn't know what was there. We knew there were polar bears and there were seals and other large marine animals. And it took a huge amount of work. And it was not easy to get it going, because in that area between Alaska and Chukotka, Russia, is the Bering Strait. And it's a very narrow strait, 50 miles to 70 miles and some nautical miles in some areas. So you have all these border guards from both sides, Russian border guards, American border guards, the Coast Guard. And we had to get all of the paperwork done and accepted. So we once were coming around the two Diomede Islands in the center of Bering Strait, and the Coast Guard says, "Stop. Do you realize you're in American water? Stop." And so I was on the radio and said, "Yes, we do. This is an American and Russian expedition. And if you look on your computer, you will find a lot of information was put there about this, and all the permissions from the State Department and your leaders in the Coast Guard." And they asked me to fax over some of the information. So I faxed over a 60-page document, and they never bothered us again.
Oh, my God. Well, it sounds like your career has been so phenomenal. I just want to thank you, Dr. Kathy Crane, oceanographer, deep sea explorer, and clearly a mentor for many people, for joining us on the Rising Tide Ocean podcast. Your background and contributions are amazing.
Thank you very much. I appreciate it. I appreciate you inviting me to participate.
Thank you for joining us on the Rising Tide Ocean podcast. If you enjoyed this episode, don't forget to subscribe on Apple, Spotify, or wherever you listen, and leave us a review or share it with your friends and other ocean lovers. Follow us on Instagram and visit bluefront.org for more updates and additional resources. Rising Tide is a production of Blue Frontier, co-hosted by David Helvark and me, Vicki Nichols-Goldstein of the Inland Ocean Coalition, with production support from Holden Hardcastle of Fluid Studios, Natasha Benjamin, Kelly Bates, and Nick Paz, and editing services provided by Charles Landon of Studio Cape May. Thanks for listening, and until next time, stay hopeful and stay salty.
Off in the salty ocean, off where the waves roll free. The sparkling water rises, then crashes to the sea. Out amongst the breakers, you'll have no need to fear. It's true, it's the blue frontier. Off in the salty ocean, off to the blue frontier.
Sparky, come here, buddy. Sparky! There you are. Good boy, Sparky.